Was wird daraus, wenn der Bruno mal tot geht? Wo landen die?
Alrighty. Sweet. Okay, I think we're ready to go, guys. Thanks for your patience and for starting here. We're starting here a little bit later than we originally planned, but it's 6 o'clock. We're going to get right into our workshop today on just networks. It's just going to be an introduction to computer networks, so it's not going to be too complicated today. So before I get into it, though, my name is Marianna. I'm the VP of Communications. Basically, I just run the social media for the club and do marketing and all that stuff. I kind of own more than just one outfit, but we do handle the newsletter. I run our Instagram, Twitter, Facebook, LinkedIn, all those things. So a little shameless plug, if you aren't following those right now, go check those out because, it takes a bit of effort to do that. So thank you in advance. We do have some attendance for you guys to fill out. So it's super important that we fill out attendance because it allows you guys to vote in our annual and general meeting at the end of the year or semester. So we have a QR code up on the wall, or you can follow the link. I'll give you guys a minute to do that. Okay, well, if you need more time, you can just pause the stream, but otherwise we're just going to get straight into what we're going to cover today. So pretty much a little quick outline. We're going to quickly cover what are computer networks. We'll go over topology diagrams, the TCP IP model, and that's basically just the information part. And then afterwards, we're going to go more into Linux commands, like Linux tools that you guys can use to explore computer networks. That's with Nmath and Netcat. And we're going to do some filtering with Wireshark, which is something you guys can use to filter through web traffic, which is pretty neat. We have a couple of challenges there where you guys can get flags, and it's just a bit of definitions to start. So just bear with me with those, and we'll get right into it. So networking, it's not the kind that you might think. It's basically just how computers communicate with each other. And there's a couple words for networking, but the one for today that we're going to be talking about is computer communication, that kind of thing. So pretty much packets, I want you to think of these as like packets of snow or like little snowballs. They're formatted data across a network, so I'm going to use that word a little bit. And network devices is just like your computer, your phone, anything like that. Internal servers that are connected to a network. So anything that pretty much is a device that connects to a network is that. And all network devices contain these little chips called NIC cards, these network interface cards, and that's kind of what allows the communication to occur. So that's just a little important thing that we want to understand. A couple kind of pros. Oh, let me just get rid of this. So a few benefits. Basically, we have some file sharing that you guys can do with computer networks. It allows us to share resources and access remote servers without having to store all that stuff on local computers. So it just allows remote access. It's pretty nifty. Also allows quick communication between users. It's just the future of technology. So we always want to use networks whenever we can in that regard. And the last thing, which is most important, is that it's very secure. There's a lot of important protocols that we use that just allow everything to be nice and safe and secure for when we transfer data. So couple great benefits. We always want to use networks when we can. So just the topology diagram. So there's a couple kinds of topology diagrams. We have like bus, the star, those kinds of things. But the most basic way that I'll be explaining it here is just this little diagram here. So you're going to have two kind of people, for example, Bob and Alice. So Bob has a computer, for example, and he's going to use a wireless kind of connection. And Alice has a physical connection for her device. So typically, you're going to have your network device connected through their NIC cards, either with a cable or wirelessly, like with Bob or Alice, to a switch. So, if it's physical, it'll be a switch. Otherwise, it's going to be an AP Next up, those two things are connected to a router, usually with switch or with cables, and that will all be connected to a firewall, which kind of just keeps you safe, prevents you from like strange things from the internet coming to you. You guys probably have all heard of firewalls, so that's what that is for. And ideally, you're gonna have these kind of steps will be kind of squished into one. Like if you have one home router, it's not gonna be like a whole bunch of little steps. It'll have all these things kind of combined. Like you might have a switch combined with a router and firewall all like wrapped up nicely. So it depends on your home system, but ideally that's what you want. So, and that firewall then is just going to reach out to the remote, talk to the internet and that kind of thing. So you'll go from, you know, switch, router, firewall in that sort of kind of order. Next up, okay, OSI model and the TCP IP model. So for our purposes today, we're just going to talk about the TCP IP model. The main difference between these two guys is that one of them has just more layers. It's kind of the same idea, but I want to teach it with the TCP IP model because it's pretty popular. We're just going to kind of condense the top 3 layers, application, presentation, and session, into kind of one general layer, but this is going to accomplish pretty much the same thing. Also, we might see the network interface layer at the bottom. This guy might often be split into 2 more layers. So instead of 4 layers, you might see the data link and physical layer present there in the TCP IP model. So you might see application, transport, network, data link, and physical. So just for your reference, you might see it in those 2 forms. Yeah, so jumping straight into it, the application layer is just, usually it's the top one, and it's just where we access network services. So for example, one you guys might all know is like HTTP. If you're just accessing like a network or something like that, or making a DNS request, that's going to be through the application layer where that request happens. Next is the transport layer. Data is transported across the network. It's going to select 2 protocols to do that. So I'll get into those protocols right now, actually, just so we're going to take a quick little detour. The top 2 protocols that we can use is TCP and UDP. So the main difference between these 2 is that TCP is way quicker, or opposite, it's not quick at all, but it's very accurate. So it's going to be a constant, strong connection. That's TCP, and UDP is known to be a bit faster, but it's not as accurate. So UDP is used for like video streaming, where it's going to be nice and quick. It's just focusing on hurling those packets as fast as it can at your computer, nice and quickly, but it's not always going to be accurate. That's why your frames might drop or something when you're video streaming. And TCP, that one is just, you know, it's pretty reliable. It's nice and strong. So ideally, if you want to have a nice, strong connection, the layer that is transport is going to be TCP, but it really just depends on what the application layer is and that kind of thing. And speaking of TCP, we got to talk about the TCP handshake. So there's basically just 3 steps before we can officially have communication. And because that, like the TCP handshake is so strong, it just makes the connection strong. So all you kind of have to know is there's just the SYN ACK, and then ACK. So the client is going to synchronize with the server. They kind of ask the server, hey, I'm going to do this thing. The SYN ACK is just the server saying, okay, I'm acknowledging that you're doing this. And then the last ACK is the user saying, okay, I acknowledge that you're acknowledging me. So it's kind of a little redundant, but it does make a really strong connection. That's just how the handshake works. Again, nice and strong, nice and secure. So with that transport layer, we pick one of those 2 protocols and go from there. Next is the network layer. So we're going to break up the data into little packets, and we're going to route them across the internet to the destination IP. So this is the layer where we kind of get the source IP and the destination IP are going to be assigned and figured out, and then we're going to start sending stuff off. This network layer is also known as the internet layer. You might see it written as that, but it means the same thing. So we're kind of just, to put it simply, you're kind of like assigning IP addresses and figuring out where you're going and just picking the most optimal route. What's the best path that we can take and that kind of thing. And lastly, the network interface layer for the TCP IP model is, again, it can be split up into data link and physical layer. So the data link layer just basically breaks up those packets even further into little frames and sends those to a destination with like their MAC addresses or their Ethernet or whatever you're using. It's going to kind of figure out, okay, now I know where I'm going. I'm going to make the data even smaller. I'm going to send it off. And then the physical layer is just, think of it as just physical transmission. Those frames are now becoming actual binary data, and we're physically moving them through cables or something like that. moving the raw data just across the network. So it's the very last step. So that being said, we are now going to do one more quick visualization before we get into, before we get into the actual challenges that we're going to start with. So how a request actually works, how it comes to be, is going to be through the model as I've discussed. We're just going to kind of break it down. So the first thing we're going to do, we have Bob. He wants to access maybe a website, and he has to make a request. So that's going to go through he's going to make his request to the web page server. And since it's a website, it's going to be a DNS request, which just stands for the domain name service or something like that. We're just going to kind of try to figure out, we have an IP, what's the domain name with the IP, that kind of thing. So we're going to do that. And then next up, we're going through the transport layer. Basically behind the scenes, DNS is going to use the transport layer protocol of UDP. So it's going to pick one of the two. Typically, if you have DNS, you're going to go with UDP. It's just nice and quick. So that layer is now established. Moving on to the network layer, the IP of the Bob, the client, and then the IP of the server, which is going to be our destination, is all established. We have it nice and packed in. That's our next layer. And lastly here, the Ethernet layer is added. We know where we're going. We're now physically going to transfer those bits. So now we have this kind of big, tall cake that we've made, and we're going to move it along to the receiving end of the server. So the server is going to see the network interface layer at the very top, and we're going to kind of slowly unpeel the cake, I guess. So it's going to read the Ethernet. It's going to read the IPs that you put in. It's going to read, oh, this is UDP. I got UDP now. This is what I want. And finally, the answer is going to be, okay, I'm doing a DNS. They want a DNS request. They want to access this website. So we finally received our answer. So the server is going to do kind of the reverse process, and it's going to reconstruct its answer. Starting at application is going to build, okay, here's what you want. It'll build it up that way with application, transport, give you back the UDP. Put you as like them as the source, you as the destination IP. And lastly, tells you where it's going to go. It'll go back down and building it up itself. And then you're going to receive the message as Bob, client. He's now the client. So he's going to now build it up the exact same way that the server kind of broke it down. And then he's finally going to get an answer. So he's finally at the very top, he'll unveil the thing he requested. So it's a little bit of a process. You're basically stepping down and then rebuilding and then unbuilding, rebuilding. But that's the general idea. I just thought it might be easy for you guys to actually see it in motion, that kind of thing. So I just broke it down there. So that being said, it was kind of a lot. If you have any questions right now, let me know. Otherwise, we'll get into the fun Linux challenges. I think we're good. So we're going to move on to Nmap. So before we even try anything, we're going to do a quick little demo. Yes, okay. So Nmap is just what we're going to be using to scan a network. It depends on network conditions, that kind of thing. You're taking an IP and you're going to scan that IP and just see what kind of information you can find on it. What's some juicy information you can find. The thing about Nmap though is it's kind of not allowed in some establishments. It can be a little bit like it's honestly not very ideal to use if you don't permission. If it's in this case that we're teaching it, you guys have permission to, so you're going to be allowed to use Nmap. But just keep that in mind. You're not going to want to just Nmap scan every single thing that has an IP. Just be cautious of that because you are scanning through scanning their ports or scanning their IP and that kind of thing. So just be responsible with Nmap, pretty much. So now we have an IP. We're just going to go for it. We're just going to try to scan this thing. And I just want to see what you guys will come up with. There's going to be a lot of ports, just for a heads up. So don't be intimidated. I will actually do this one with you, so we can kind of see how that goes. Just grab this. Okay. Yeah. Okay. So the command is just nmap. Oh, and then we're going to put in this. We'll kind of give you guys a second to get there. And let me also. There we go. Zoom in a little bit there for you guys. Okay. So, and Nmap also might take a hot minute to load, but essentially we're now just scanning through this IP. 142.93.58.251. So I have it up on my end. So I'll just kind of start explaining. You might see a lot of stuff here. What I want you guys to actually do, I'll give you like another 5 minutes to do this. You're gonna take the IP address, and then you're gonna take the port, and you're gonna actually explore with those and see what you can find with them. For those of you who might not be familiar with maybe web exploitation or how to find where something is based off of a certain port, the port number is kind of just the destination where this traffic is occurring. So I'll just do a quick demo, I guess, for one of them. Why not? Let me go to this tab. Let's just put in this, and let's go to port, I don't know, port 22. Let's see what's over there. And it's restricted, so that means I don't want you going there. We're just going to try out all these ports, see what you guys can find. If there's only 2 pages in here that are special, there's no flags yet, but I just want you to find the 2 pages that have like a special little message on them. So I think you have 7 tries. I'll give you like 30 seconds to do this, and then I'll just show you guys the answers, because this is just a quick little demo, just showing you how to kind of get an IP and then a port, and then how to find it, use it to search, which is what I just showed. And then just get familiar with Nmap, because it can look a little weird at times, but all you're looking at is, okay, we have ports, we have just states. This just means, okay, the ports are open, which is a good thing. And then just the service, I would recommend looking into this a little more on your own if you'd like. But for example, some things we might know is like SSH. We're not going to be dealing with that. HTTP, we might want to deal with HTTP. If you know what HTTP is, it's like web server stuff, like website stuff. You might want to check out this one. And a couple of these you're not going to, if it looks funky, you probably aren't going to want to touch it, but that's just advice. So yeah, try those. Give you guys a quick second, and then we'll resume. So, second. Okay, I'll just start showing them. Yeah, if it seems kind of odd, then stop and don't try to investigate it, because this is just the demo. It's supposed to be nice and simple. So I will just show you guys. Spoiler alert, it's going to be port 80 and port 8080. So let's go to those. Port 80, just FYI, is just your default port. So even if I type in port 80, it's just going to be the IP. If you just Googled the IP address, you're going to get this. It's just one page. So on port 80, I just wanted to show you guys that. And then just on port 8080. Hey, there's something else. Port 8080. That's pretty cool. So that was just to show you guys how to kind of use the IP to connect to the port, which most of you might be familiar with, but just in case, that is why we have that there. Now getting a little bit more in details, because we want to get into a little Nmap challenge. So I want to teach you guys a little bit more about it. So, oops, that was that. Sweet. Okay, so with Nmap, you're going to notice we have a couple little flags that we can use. That's just those little things that we can add on to our command. So TACP is going to be very important. It just means we're specifying what port range we want to look through, because typically with Nmap, you have a very limited amount of ports. It will just automatically scan for you, because there's a lot of ports. Hint, hint, that's going to be important for later, but it's a very, very large number. So we don't want to painfully scan through every single port all the time. So usually Nmap will just scan your top most popular or the top most used ports for information. So, and in our case, though, there might be flags hidden somewhere else. So basically, you're going to use TACP and then the start of your range to the end, or you can just do TAC to look through everything. However, that will take you a long time. Might even take 5 to 10 minutes. So I'd recommend not really doing that unless you really want to just sit there and let it run. So you're going to do TACP, start, $, space, and then the IP address. So that is going to be how you run a nice detailed Nmap command.
So start is the starting range for the ports, right?
Yeah, so it's a starting range for the port. Yeah, that's good clarification. So it's like if you want to look through ports 100 to 200, it'll be the first start port dash the second port. So 100 dash 200. So that's just how you kind of scan through a range of ports for that tag. Also, one more important thing is verbose mode. This is more of like an optional tag, but I would recommend you guys kind of learn about it because it'll tell you more information as you use it. Just saying TAC V, it's going to print out some extra notes. And if you do TAC VV, it'll just be even more verbose. So I would recommend the TAC VV. Basically, if you're just sitting and waiting for an Nmap scan, if you have TAC VV running, it's going to print to you, it'll tell you some information as you wait. Instead of just sitting there twiddling your thumbs waiting for nothing, it'll tell you as it goes saying, oh, I found this port, or I found this port, or I found this is open. So it's kind of helpful so you're not wasting a bunch of time. You know, it'll tell you some information that you're looking for. So TAC-VV is quite nice. Now we're going to use that same IP from before, and I'm going to give you guys a hint. There's another flag hidden on a very large port. So you're going to have to look through the port range. 60,000 is as the lowest end. And then the largest end, you're going to have to figure out. So maybe you might want to use Google. Might want to ask, like, oh, what's the largest range that a port can be so you can know what you're looking for, what you're looking through. And then see if you can find that flag. Once you get the flag, you're going to get, well, first you're going to get a port number. And then you're going to use that technique we explored a little bit earlier where you have the IP address, port. So see if you guys can find that. I think I have a little bit of some hints right here. Yes. So a couple useful flags. Maybe you use them all, maybe you won't, but I'll give you guys 10 or so minutes to figure that out. So let me just mute this and then I'll come right back and we'll talk about the solutions. Okay. Okay, guys, we are back. Alrighty, so we are going to go over the solutions. I'm pretty sure everybody in the room figured it out pretty quickly. It just takes a second for Nmap to scan. So when you guys first run the scan, first of all, you're going to figure out that the largest port range is going to be 65,533, and you're going to put that as the highest range that you're going to scan for. You're going to get a whole bunch of information here, and it might look like a lot. That's because we put on verbose mode, and why I like verbose mode so much is because it's going to tell you little hints. So for example, right over here, as we were scanning, it told me some like ports that were opening up that we see. So while I'm working, I can honestly just end the scan right here. As soon as I got to this line and I saw this right here, I'll know, okay, there's a port here. Very suspicious, an open port on 64283. And if we were to just wait the whole time for it to finish, you're also just going to see it over here as well. 64283, unknown service. So a little bit suspicious, so we're going to check it out. See if I can pull it up here as well. That was 64283. Beautiful. Got a little flag there. So web scraper. That is your first challenge done. So make sure to grab that flag, put it in, submit it to Orchid, and we are good to move on. Question?
How were you able to cancel the scan?
Oh, yeah, good question. I think it's just Control C or Control Shift C. So if you're in the middle of a scan and you want to just stop it or it's taking too long, I believe it's just Control C. Otherwise, just spam that and that should cancel the scan for you. Sweet. Good question. Alrighty. Great. So now a little quick tool we're going to use that kind of piggybacks off of Nmap is called Netcat. So it's going to be a tool that we can use to connect to things remotely, or we can just listen to a certain port number. We're going to use that to kind of find out a couple more things. So we can transfer files between computers with Netcat, and we can also listen and monitor network traffic between computers. Those are the two primary uses for Netcat, but we're going to explore a couple over here. The command for writing is very, very simple. You're just going to type NC for Netcat, then IP port number. So there's no fancy like TACP or anything like that. It's just straight up IP port. So it's just going to take that form. The port, again, for quick little definition, in case you guys don't really remember, a port refers to a destination for a certain type of traffic to occur. So that's why the port number is so important, because there's so many different ports that are open on an IP address usually. So you want to listen to something very specific, you're going to put in the port number for Netcat. So that's what that is for. So another little quick challenge here. This one is a little bit more demanding because you have to first use an Nmap scan and then do the Netcat scan afterwards. So the port range this time is a little different. So it's going to be from the range 2000 to 4000. So make sure you include that in your Nmap scan. And then I want you to try it out with the little hints on the bottom of the screen. See if you can find anything there. This one hopefully won't be too bad, but if you guys have any questions or anything like that at all, I'll be walking around to see if I can give you guys any helps. So, one quick second. Okay, alrighty, we're back. Okay, guys, so we're gonna just go over the solution really quick. Most people in the room have figured it out, so it's quite simple. We have the Nmap scan once again from ports 2000 to 4000, and if you just look through the verbose mode of the scan, you're gonna see that we have a very fancy port at 2345, and we also see at the very bottom right here. So now that we have this, we can do the netcat scan. So I'll just do that really quick. If you were sneaky about it too, you could have also just took the IP and then just went to the port and just found the flag like that. But that's not what this is about, you guys. We're gonna actually, whoops, actually put in NC this, and then it's gonna be 2345. Nice, another flag. Here, kitty, kitty. So with that being said, okay, thank you. We have just two more things that we're going to cover now. So let me get right into those. We're going to start with, before we move on, no questions about Netcat? We're good? Sweet. Let's go. Okay. From there, Wireshark. This is going to be a super fun tool that we can use for filtering and just filtering traffic that we get to see online. So you can use Wireshark whenever you want, but it's best used in controlled environments, of course. It's basically just a network traffic analyzer, and it can be used for troubleshooting, or if something's going wrong with your website or something like that. You can use Wireshark to check out the traffic and just see what's going on behind the scenes. So when you open up Wireshark in Kali, the first thing you want to do is just start capturing packets, which is just the blue button in the top of the screen. That's just if you want to make a recording or just capture packets. For this workshop, I'm going to supply you guys with the PCAP files. That's just the files of pre-recorded traffic information. So you don't have to worry about capturing anything yourself, but just for your knowledge, if you do want to do it yourself, you can capture packets this way. There's just a few important things I want to talk about. The thing about Wireshark, though, is that it's very detailed. There's a lot you can learn about Wireshark, and this is just an introductory level workshop, so I highly recommend you guys look into it on your own, but I'm just going to cover some very, very simple filtering techniques, just some little tools you can start putting in your tool belt, but I'm definitely glossing over a lot of things, so just keep that in mind. The very first thing, and then this is arguably, in my opinion, one of the more important methods of searching through data, it's going to be frame matches. So to search for a very specific text in your packet, which will be important for a challenge, you're going to use frame matches and then whatever the text is. Ideally, you're going to use quotes in that search because it might cause issues later. And then if you look at the very bottom, so if you see in the slideshow, the very bottom right corner, this is where you're going to see where the text is, and it's going to filter through whatever text is found in that little location. So when you're doing the challenge as well, you're going to look down there for any hidden text or anything. That's what the text is going to be. So frame matches text. The next one we'll talk about just for your reference is one called, it uses the TCP protocol as we discussed earlier. It's just TCP contains and then in quotes the text. So that's usually if you're going to have a TCP protocol or something like that, and you want to analyze that three-way handshake or something like that, you're going to use that. So the thing about TCP contains is typically if you're searching for text, it won't always get you the exact answer you want. It's not as concise. It's just, for me, personal opinion, it's not as nice. But I'm also still a beginner with Wireshark. There might be something I'm missing, but typically if you want to find something, frame matches is just easier to use. Now, if you want to look for a very specific IP, so if you're looking through traffic between two things and you know this is the IP I want to look for and you want to just filter down your traffic, you can just do ip.adder equals and then the IP address. Similarly, you can also look for a specific source or a destination IP. So if you want to look for your IP, you can do .source, CRC, or if you want to look for a destination IP or some other IP, you're going to do ip.dst equals whatever IP it is, and that will help you in that regard. So just a couple things about, like, typically when you're searching, you will look through, like, what is the IP addresses I'm using, what is the text that I'm looking through, those kinds of things. There's a lot more you can filter through. There's a lot of things, but just for our purposes, those are the more things that stand out to me, and it's good to kind of start understanding those things with Wireshark. So there's that. So next up, I'm gonna give you guys a PCAP file. If you go to InfoSecu Calgary, you can find this link. Otherwise, I think I might be able to. Can we put the link in the YouTube chat? Yeah. So we'll put the link for you guys. If you want to open up the live stream, then go to the chat. We'll have in the information security U Calgary chat box, I guess. We're gonna have that link in there. It's a safe download. Trust me. You can download it. And you're just gonna want to make sure that you're opening this inside Kali or inside the virtual box so that it'll be able to be downloaded and you can use Wireshark to open it up because the tool Wireshark is going to be on in Firefox. You don't want to make the mistake of opening it in your Windows machine or something like that because you won't have Wireshark installed. That might just be confusing for you. So take the link, grab it from the chat, and then go over to your Kali, like open your Kali back up, and then you can just search for it in Firefox, the link, or you can type wget in the command line, wget, and then this link, and that'll just download it for you in whatever directory you're in. So might be easier to use the command line, but if you're not sure how that works, paste that into Firefox, a link, or type wget, one word, wget space the link, and then it'll just download that for you. And then you can type Wireshark space, and then whatever the link is, and then you're good. So I'm gonna give you a second to look through that. Just a heads up, the flag is gonna be, you're gonna have to type out UCSec, the username that you find, and the password you find. So just for a reference, what I'm getting you guys to do is basically, you're taking this website, someone was trying to log into something, and I've given you a PCAP file that is just tracking someone's information as they're typing their username or password. We've secretly been kind of checking out what they're doing, what's the username and password that they entered, and that kind of thing. So we have a PCAP file that you guys are going to look through using the frame contains or TCP contains frame matches kind of keywords. And you're going to look for some keywords that might have something to do with a username or a password. Think about maybe what are some buzzwords? What's some keywords that might give you some kind of results? I don't want you just guessing usernames or passwords. Actually try to just like think of keywords that might be, I don't want to say too much without giving it away, but there's that. And this site was actually from a YouTuber called Vincelove Academy. So I didn't build it myself, but I did make the PCAP file myself and did some typing in, that kind of thing. But the idea is from this YouTuber, so if you want to check him out, it was very, very cool and helped me learn more about Wireshark. So feel free. I'll go back to this slide as well. Make sure that, you're going to get a username and password. Make sure you put it in the flag format. If you have any questions, let us know. And I'll give you guys 10, 15 minutes for this one. See if you can find anything. If you have any questions, I will be happy to answer them. Is it lagging?
Because I know how like this equivalent of like these the dash and the star.
Yeah, so that's what we're at. Yeah, I saw that. That's in, yeah.
One second.
I don't want it to crash.
There we go. Awesome.
Great. All right. Sorry for the technical difficulties. We're back now. It looks like we're good to resume. So, alrighty, I'm just going to show, whole demo. So, in case you have not been able to find that flag or just find the user admin, that kind of thing, we are going to quickly show you guys. So, if I just go, hang on one second. Yeah, okay, it's going to be. There we go. There we go. Okay. So the primary thing that I wanted you guys to take a look at is frame matches. Let's see if I can close that. Okay, so it might be a little small here. Let me see if I can zoom in. No. Okay. Well, there we go. Sweet. Okay. So we're gonna look for frame matches with our quotes. And now I told you guys to look for some buzzer words that might just show us, you know, a username, password, that kind of thing. So I'm just gonna do that. I'm gonna let you look for a password, because that's what we want to find. We just want to find a username or password to get that flag. By pressing enter, we get a post request, which is kind of, it makes sense because when you submit something on the internet, you're going to get a post request. So that's probably what it is. And if you look over here in the text fields, just by looking through all this encryption, if you just scroll all the way down, we have login results. This is just the version number, the version type of our computer. Firefox, we're using Firefox. It's accepted. Keep going, keep going. There's some more gibberish. And at the very bottom, we see something very special. We see insecure requests. We have under this parameter, text username, we got a username. And under text password, we got a password. So because we didn't really know what the parameters were for that text field, like from earlier, there was just a username and a password you guys could search for. We don't really know much because we're just trying to find stuff using our filtering skills. So we just looked for password in general and we were able to find it. So the flag is going to be ucsec admin underscore admin 12345. And let's just see what happens if we try to do the same method, but we don't use frame matches. Like if we were to just try the other method, TCP contains, it might also work, but there's another, it doesn't work. Yeah, so that one I believe has to be very specific. So if we actually try to do admin, if we know what we're looking for, it's going to pop up because that one shows admin. And I think if we do txt username, if we know what the parameter is, for the text file, it'll also show up. So that one, again, it's reliable if you know exactly what you want. But if you don't know anything, you want to look for some frames, just use frame matches. And that's how we can do that. That's going to be important for the next challenge as well. So just don't forget about it. Just remember that. And now we're going to do a little fun thing called regular expression. So if you're taking 351 right now, you're going to be learning a little bit about regular expression. But for those of you who don't actually know, we are going to cover the basics. So it's just a way that we can filter through things or find strings. It's typically just known as pattern matching. So we're looking for patterns in strings of text. We can do a lot of filtering with Wireshark and using regular expression. If you're coding as well, you can use regular expression usually encode, define certain strings or find things. It just makes your life easier when you're filtering. So of course I'm going to cover regular expression. Just make sure when you're using Wireshark that you're using those quotes, because it won't understand regular expression if you don't have the quotes around your search. So just make sure you guys are using those. A couple common things that you will see is the period, the plus sign, the question mark, and the asterisk, the little star closure. So with the period, if you do period something, it means that any character is valid, any character, I think, in the ASCII text. So you can have the example of cookies. If you do co.o, blah, 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 there can be any letter there, A, B, C, D, in that little spot. Same with, I think, capital letters, all the kind of things. So any character can exist where that period is in regular expression. With the plus, so the two most common ones you will also see is the plus and the star. So it means that the character right before the plus is going to be found at least once or more. So it's going to exist there. The character will exist there, but one or more times. So with cookie, the second O is going to exist there, but there could be 2 extra O's. There could be 3 extra O's, 4 extra O's. That's what the plus means. And the star, a little bit different. It just means it's going to be found, the character will be found 0 or more times. So there could be that 0 could, or the O could not exist there, or it could appear 1 time or 2 times or 3 times or any number of times. So just be careful about those differences. One of them is just it could exist once or more. That's the plus closure, and 0 or more times is the star closure. And lastly, the question mark is just a little thing for you guys to know, just for your reference. It means the preceding character that's following is optional. So, for example, you might see it more commonly with plural things, like with the example cookie. It might just show cookie, cookies. Could be any character there, like A, B, C, D, whatever character. It's also commonly seen for the HTTP. You might see like HTTP question or S question mark, because it might be just the not secure version or the secure version, HTTPS versus HTTP. So if you're using regular expression for that, it might be helpful to use a question mark. So we're going to do a little example because there's a lot you can do with regular expression. This might look like a lot. It might, because it's a big string of text, but it's actually a lot more simple when you break it down and really think about it, because it can be broken down. That's how we're going to do regular expressions, is we're going to think about what we just learned and apply it. So for the starters, on the very end of the string, there's a little caret symbol and a $sign. That just means we know we're looking for an exact string. So everything from the start is the caret symbol means this is the start of the string. And then the $sign means, okay, this is going to be at the end of the string. So if we trap it in between the caret and the $sign, it means this is an exact string, and we're just searching for it here. Inside our big square brackets, we're looking for a set of information containing whatever is contained in the sets. So we got the alphabet letters from A to Z, lowercase, uppercase, underscores, dashes, periods, that kind of thing. And you might see that we have some backslashes in here as well. The backslashes just mean that we can use special characters, and we're not going to get confused with the regular expression meaning for these characters. So for example, the dot, the period, we know that from earlier that it has a special meaning. It means like if there's at least there's like one or there's any character is valid in this spot. So if we do a slash, it just means that there can just be like a dot. So it just means there is a special character is allowed to be here just as a dot. So no special meaning there. If we move on, we look at these little plus symbols. We know what this means. Any character in this bracket set, so in the alphabet from A to Z, 0 to 9, all those things in the brackets, anything prior is going to appear once or more. So anything in here from above is going to appear 1 time or more. At the very end, if we look at the back of the regular expression, we have these curly braces. So we know the set of from the alphabet letters A to Z, lowercase and uppercase, are going to be seen. And the curly braces just mean we're specifying the number of times that the prior values are going to appear. So for this example, they're going to appear from 2 to 5 times. So you'll see the letter A. You might see AAA, BBB, CCC, or ACB, ABZ. Any number of characters between 5 or 2 to 5 times inside the brackets before. So that's what that is. And then lastly, just these 2 little characters here, they just mean exactly what you think. It's just the basic character. We're going to have an @ and we're also going to have just a normal period, not the fancy period, because it's / period. So in our string, we're literally going to have an @ and we're literally going to have a period at those locations. So do we have any ideas what we're looking at? An email address. Someone got it. Okay, we're looking at an email address. So this is a regular expression to find every email address in existence. We're looking at the username, the @ if that might have given you a hint, at domain name .com or .net, .ca, .gov, all those kinds of things. So that's basically a simple regular expression that we just broke down. It honestly doesn't get much harder than this. So if you guys understood that, you're killing it. So that's good. Now, this is our last challenge, you guys. So it's going to be another PCAT file thing. We're going to have to send you guys the link once again in the chat. So you're going to have to open up the Information Security Club YouTube account, and we're going to send the link over there. In this flag, though, we have some special characters from C to T in this, like, in no particular order. But what you're going to be doing when you're filtering is you're going to use some of the symbols you've learned. You're going to use those set notation, those brackets, use all these characters. And also keep in mind that you're looking for a UC-sec bracket, something inside another bracket. So when you're filtering, make sure you have those the quotes around your search. You're going to use some things you've learned earlier, like TCP contains or frame matches. So I'm going to make sure that you guys have access to that link really quick, and then you guys are good to go. You have 20 minutes, and then I'll just show you guys what the solution was. So give me one quick second. I'll get that link pasted for you guys.
Well, no, like, the thing is that you-
Oh, and it's doing the thing again.
Camera's bugged, I don't think it matters.
Doesn't really matter.
There we go.
Okay. Yeah.
And present.
Okay.
No, we have an assignment.
Sweet. All right, so now we're gonna actually go over the solution. Sorry about that, you guys. Little technical difficulties. So back to the slides. So as you guys know, you can use frame matches and then the brackets to search for something. And we know that every flag starts with UC-sec, a curly bracket, and then there's something inside. If you were to just try to look for that, you're not going to get any results because we want a specific flag, but we don't know what the characters are. So the hint that I gave you guys is it has these letters. So if you use the email example from earlier, you just want to look for a set of something, and it's going to repeat one or more times. So for example, the letter C is in there, so the letter C is gonna appear in the string at least once. So you use the plus closure. Also, you're gonna have the letter F, L, I, N, R, S, T. All that stuff is gonna appear at least once. So you can use that method, just the brackets, and search for all those characters, plus, and then curly bracket close. So you're just using regular expression. There's also a very sneaky way if you were able to find it. Very, very simple, nice and clean. If you just look for UC-sec, curly bracket, and then just dot plus. This just means that the dot means for every value. So for every character, it's going to appear once or more times, and it's just going to keep appearing, and that's going to get you the flag. I will not tell you what the flag is. It's going to be a secret. So if you want to actually get the flag, try these in the search bar. Filter for this. You can try there's three methods. There's a very quick, clean method, just dot plus. Or you can try looking for all the characters in the flag and then put it in brackets and then say that these characters will appear one or more times. And that's just going to be a nice, clean way of searching your regular expression. So that is that. Some related courses is Computer Science 441. That's going to be the Computer Networks class. I personally have not taken it yet, but I'm really looking forward to learning about it. It's a very, very cool class from what I hear. And you learn about all these things that I've talked about in a lot of detail. We also have two really awesome workshops that I recommend you guys check out if you want to learn a little bit more about networks. We have the scanning and buzzing tools by Delara from last year and the Wireshark by Brandon from last year. Those are two really, really interesting workshops, and I had to watch them to get some information for this one as well. So these ones might be a little bit more advanced, to be honest, but I still recommend you looking at them because you can just learn a lot more. So that being said, thank you so much for watching and for learning. I hope you guys learned a lot, and feel free to tune in next week. We have a speaker series, so you guys will also learn a little bit about what they have to say. It's all going to be virtual, so nothing is going to be in person for next week. But I hope to see you guys on the live stream or on Twitch because then you'll be able to tune in that way instead of just being in person. So that's just for next week. Hope to see you guys there. And again, thank you so much for tuning into this workshop. Perfect. Yes. Stay safe, stay healthy. We're out.